I'm Brigitte Händler.
And I'm Rivki Vinanto. And together we'll be showing you some more highlights of WinCC Unified in theory and practice.
WinCC features a modern user interface which supports the free design of user interfaces and a variety of different graphical options with reusable elements. Key aspects here include vector-based SVG graphics, first and foremost, and a sophisticated faceplate concept as well. This saves both time and money and enables any visualization to be used on a panel just as well as on a PC system.
Let's talk about SVG graphics first. These graphics enable the flexibly, scalable, razor-sharp visualization of graphical objects, regardless of whether a unified comfort panel with a 7-inch display or a PC system is being used as the target platform. WinCC Unified provides a comprehensive library of industrial objects as static and dynamic SVG graphics. With dynamic SVG graphics, parts of the graphic are externalized as interfaces which can be made dynamic in WinCC Unified to implement color changes based on process values, for example. Modern design concepts can also be implemented in this way. Even more advantages are offered by the new faceplate concept. A uniform standard and consistent operating concept from the panel to the control room are implemented with it. Now I'll explain how the type instance concept of the faceplate is used. Faceplates are defined using common data in 3 steps. Visualization of the object, such as a motor and the associated operating screen. Definition of the interfaces, simple text or UDT. Features of the interface, such as colors and resource lists. Predefined faceplates are then dragged and dropped in the corresponding location, as usually in TIA portal. The interfaces are then linked to process variables and the appearance is specified on the screen. After creating a new faceplate instance, we specify whether it is about the appearance of an object, like transparent background, or an operating window. In the case of the latter, properties can be defined, such as show heading, show border, can be closed, and so on. The definition of the interface is made on the Tag Interface and Properties Interface tabs. A common scenario is an asset, such as a motor with an unassociated operating dialog. Both are separate faceplate types with uniform interfaces. The associated operating dialog is then opened as a pop-up by a script when the mouse is clicked. It is not necessary to place the operating dialog in the screen in engineering. The pop-up is displayed using the predefined Open Faceplate in Pop-up function. When called, properties like the location of the pop-up are also passed. This enables the pop-up to always be displayed directly next to the object currently being operated. Before we take a look at this live, I'd like to mention one last point. The instances of a faceplate which are used can be managed centrally. This allows us to change the faceplate type, for example, if there is a new version, and also to see how many instances there are. Now I'll show you SVG graphics and the configuration of faceplates in a live demonstration. Let's talk about SVG graphics first. The machine visualization on the left-hand side was implemented as dynamic SVG objects. We are simulating a fault in the machine. Fault detection also directly leads to a color change of the machine part in question. Now, we'll switch to editing mode and the graphic screen. We've inserted 2 images into the screen for demonstration purposes. The SVG graphic on the right-hand side and a conventional PNG graphic on the left-hand side. When we zoom in, we can clearly see that no loss in quality occurs in the visualization with SVG, whereas the PNG object is blurry. Now let's move on to the faceplates. We switch back to TIA portal for this. The faceplates are created using common data. First, we show the visualization using an existing faceplate for this purpose. The process connection is defined on the Tag Interface tab. Individual data types or UDTs can be used here. Finally, the property interface is configured. The color or resource list can be specified as an external interface of the faceplate there. The faceplates are used by directly dragging and dropping them in the desired position in the screen. Let's take a look at the use of faceplates in the runtime. In this case, the appearance is identical in the screen and the accompanying operating pop-up. If all faceplate instances are to be changed later on, all instances of a selected faceplate type can be changed centrally in TIA portal.
Another highlight of WinCC Unified is powerful, platform-independent scripting with JavaScript. There are several reasons for this scripting language switch. The main reason is undoubtedly that a modern, web-based system like WinCC Unified also has to rely on a platform-independent scripting language. JavaScript is also widely distributed, especially in web development, and is very easy to learn. This is an enormous advantage, in particular for machine construction and automation experts who are not explicitly specialists in software development. With JavaScript, direct access to the entire WinCC Unified object model is possible. Access to the file system of the computer or databases is also very easy to implement. For frequently required HMI functions, prepared code snippets are available. We just saw one example of this with the faceplate pop-ups. The integrated debugger is activated for testing if necessary. The most obvious use case for scripts certainly has to be making graphical objects dynamic. On the one hand, there are scripts for events like a mouse click, as we saw. It's now also possible to make almost every feature of an object dynamic in WinCC Unified using scripts, and changes to an attribute can be responded to as well. WinCC Unified thus offers optimum flexibility. Naturally, scripts are also used for global modules and in the task scheduler. Frequently used functions are available as predefined system functions. Examples of this include the accessing of the object model of WinCC Unified, that is, changes to variable or access to alarm values. The accessing of screen objects, including screen changes, would also be an example. Functions like the logging out of users are included as well. For individual script solutions, it's possible to convert system functions into a new script with the push of a button. This means you get a template with the correct syntax and can then simply expand it. For script testing, the integrated debugger can be activated using SIMATIC Runtime Manager. Familiar functions like breakpoints, the incremental processing of functions, and the monitoring of individual values are supported here and help with script diagnostics. We've also prepared a small live demo for this.
In our live demonstration, we show you how you can activate debugging in SIMATIC Runtime Manager and a few scripting examples as well. First, we'll open SIMATIC Runtime Manager again. Under Settings, Script Debugger Settings, the debugger can be activated for screens or the task scheduler. Now, we'll go back to Engineering and open the Performance screen. Using Gauge Control as an example, we can see how properties are made dynamic using tag or script. We've created a JavaScript script as an event for a mouse click. With a right mouse click, the snippets of frequently required functions are displayed. The Space Controller activates the IntelliSense function for direct access to the WinCC Unified object model.
Now we've come to the last point of this series, the extensive options of the new controls, which offer a considerably broadened scope of functions. First, we'll present the alarm control for a complete overview of messages. The alarm texts are either saved in the HMI or transferred directly from the PLC as full-text alarms. We'll also show you the new trend control for flexible evaluation of current or archived process data. For PC-based WinCC Unified systems, the trend control can be expanded with a trend companion for direct statistical analysis. The alarm display can be freely configured. This not only concerns the columns displayed and their sequence, but the toolbar as well. Using flexible filters, all messages are only those messages for an individual area, such as a machine, can be displayed as needed. The filter can easily be composed using a configuration dialog. If various different filters are required, the filter properties of the alarm message can be made dynamic using a button in the screen. The trend control also offers a very high degree of flexibility. The type of display, like line, filled curve, step curve, or pure values, can also be selected like several trends within a trend window. Add to this many other functions like a ruler and flexible zooming options. The Trend Companion can only be used for PC-based WinCC Unified systems and in conjunction with a trend control. Online statistical calculations are carried out for a time period selected in the trend control. The minimum, maximum, average, and standard deviation for this time can be determined in this way. We'll show you this again in the live demo as well.
Let's go right to the runtime for this. First, we switch to the message display in the runtime. Using a simulation, messages of the warning and alarm classes are generated here if a limit value is exceeded. We set a filter to only display messages of the alarm class. A well-designed filter configurator is available for this purpose. After filtering, only the message of the alarm class is still displayed, and I'll acknowledge the alarm. If the filter is no longer required, it can be deleted again. Now let's switch to the trend control. In a trend window, we can see 3 trends and a ruler on which the values for each trend are displayed at a point in time. I'll show you some options for zooming in the trend window. And finally, the Trend Companion, which is used in conjunction with a trend control. A time window of the trend is selected using 2 moving lines. You can see the minimum and maximum values per trend for this in the companion. A static evaluation can be carried out with the push of a button. Now we get additional information for the time period, like the average and standard deviation.
Nun erhält man für den Zeitbereich weitere Informationen wie Durchschnitt oder Standardabweichung.
Thank you very much for this overview, Rivki. Should you need more information, you can find it in the video description.
Siemens. Ingenuity for life.